Okay, so this is the laminar planes question that we started on when we returned from Christmas. So first of all, I'm going to explain laminar planes for anybody that hasn't been in school yet. So just really quickly, this is what an examiner or laminar planes looks like for a higher level leaving cert question. So you're given the coordinates to a number of points here that make up these triangular planar surfaces. So you'll see here there's a little image shown. This is a building over in Qatar, and it shows the plan and elevation of basically these little triangular surfaces. So the coordinates are given basically to find each point in both elevation and in plan, and these coordinates are over here. So how these coordinates work is shown over here. So I'm just going to get rid of this for now, and we're going to look at just a very simple example. So here I have the laminar planes and the planes of reference. So I only have the vertical plane, which will be our elevation, and I have the horizontal plane, which will be our plan. Now this is shown in isometric, so pictorial, basically in 3D, just to try and show how it works. And then I've shown how it would look if it was flat on our page, like we would see when we're drawing. So we are given, say we only wanted to find a triangle, so we're given the coordinates A, B, C for this triangle. The first number here is our x value, so that's how far from the left hand side of our page that we measure along the xy line. So you can see here in the pictorial, it's coming across parallel to the xy line, and this is what it looks like in elevation. So if I wanted to find a point that is in 50 millimeters, I would measure in 50. Let me get a different marker actually. If I measure in 50, I would put a little dot there on the xy line. The next one is in 25, so I put another little dot just here, and then I put C here at 90, so C would be somewhere over here. This is if this was an A3 page. Then I could find where they are in elevation by using the y value. So let's go back to A, which was this middle point here. A will be up a height of 100, so I measure up 100 parallel to my y value, so up 100, and I would find point A in elevation just there. And if I label that, so there we have point A. If I wanted to find point B, I would measure up 60, so that's this first point, measure up about 60. There would be point B, and then point C is actually on the xy line. So there is point C, and you could draw in that little object, that planar surface. So there is ABC now shown, like that. To find them in plan, you go to the third value, and this way we are actually going to measure down in plan, or away from our xy line. We're going to measure out from our xy line in our z direction. So we'll go back to point A, which is here. We'll measure down 25, let's say put it there. Point B will be down 60, so about there, and then point C will be down 75, and we would generate a view of that surface in both elevation and plan, and it wouldn't look the same. So hopefully that makes sense, and we're going to apply this kind of concept now to this exam question. So moving on, I'll pull up this exam question again real quick. So we have been given the coordinates for A, B, C, D and E, and we've been given the partial coordinates for point F. Now we're not going to worry about point F for now, we're only going to focus on parts A and B just for now, and then when we get better at this, we're going to move on down to part C and part D. So we want to keep these sheets as neat as possible, because we will be coming back to them. So I'm just going to grab a pencil, and I can't find my ruler actually, there it is. And I will start here. So first off, I'm going to draw in my xy line, and I usually put it in the middle of the page. Just going to double check the height. I'm just going to keep it down a little bit lower because I've already pre-drawn this. So I'm just going to draw in a light xy line just here, construction line, and I'm going to start measuring my values in from the edge of my page. I'm not going to measure from the border. I'm not going to start somewhere random. I'm going to measure right from the edge, and I'm going to first measure all my x values. So I'm going to come in 145 for point A, 130 for point B, 180 for point C, 100 for point D, and 145 for point E, which is already there. So there is A, E, B is 130, so I'm just going to index this very lightly for myself. D is 100, and C is over here. So sometimes I would rub these out if they're in the way, but for now they're okay. They're very lightly labelled. Now I can measure up, and I can find all the points in elevation. So I'm just going to use the 100mm mark on my set square while measuring up, because I have no room just here above my page. So point D is up 60, and I can index that there. So there's point D, and if you look at the question sheet given, it shows a good position for the indexes. Point C is up 55. Point E is up 90, and point A is up 10. So I'll do both of those. So I'll come up 10 for point A, come up 90 for point E, point E, and point A just here. And then the last one we need is point B, which is at an altitude of 45. 45, just there. B. So I have A, B, C, D, and E. Now if you look at the question, it will show us that there are, like, we don't know which one is joining to which. Well, we can follow here. We can see A joins to D, joins to E. Basically they all nearly join up to each other, but if you come down here to part A, it will explain what planes are which. So we need to join A, B, and C together. So A to B, B to C, and C to A. Same with A, B, D, and same with B, D, E. So I'm going to do that, and I'm going to use different colors. So I'm going to use purple for A, B, C. So A to B, B to C, and A to C. Now that I have that done, I can move on to ABD. Now this is where it gets a little bit tricky, because we have a common line. So we have AB, then we have BD, so I can join that. And I have AD. Now just so that I know AB is part of this, I would also draw in a light green line just here beside it. Hopefully you can see that that's green and purple in one go. And then the last plane that we need to join up is BDE. So let's do that in another color. I'll do that in red. Join B to E first, D to E, and D to B. Just like that. I'll zoom in so you can see. So that's what the elevation should look like here now. And it's the exact same process to do the plan, so I'm just going to do that here now real quick. I'm not going to talk you through it. You can watch me doing it. But yeah, you should be able to follow the dimensions. So I have my X coordinates, which is how far in from the left to come. My Y coordinates is how far up from the XY line to come. And I have my Z coordinates, which is how far down from my XY line to come. So now I'm going to be looking at these values in relation to these points. So I'm going to find A, B, and C. The best way of doing it is to actually drop down construction lines, because they will be needed later anyway, or projection lines. And now I can measure the heights down. 70 for A and 10 for E. For C. and 20 for D. So I now need B, which is down 40. And I can join them all up now with the same colours before. So B to D, BDE, ABD, and ABC. I just realised I did that in the wrong colour. Never mind. That's meant to be green. I was not paying attention. I'll go over it now in a second. And I'll use this black. So there we go, we have the green, we have the red, and we have the purple. So now we can look at part A. Oh, we've done part A, never mind, part B. So now we need to determine what is called a dihedral angle. Now I'm just going to show a little sketch just here. So what we have basically are two triangular surfaces. So if you imagine we have a set square in elevation, and we can see the set square like this. But then we put another set square alongside it, like that. What the dihedral angle is the angle that is in there. So if we were to look down along here, we would see something like that. And that there is our dihedral angle. So what we want to get is this angle. We want to see both planes as an edge. So to do that, step one is to find the line of intersection. So to find the line of intersection, we need to find which line is common between the two planes. So if we read part B, it says determine the dihedral angle between ABC and ABD. So that is ABC, which is the purple, and ABD, which is the green. So we just want to focus on these two here. Which line is common? AB. So first step is to find the true length of AB. And what that means is to basically create an auxiliary such that the XY line, the X1, Y1 line is parallel. So I'm just going to take this AB, and I'm going to come up here. I'm going to come up actually even a bit further. Come up here and I'm going to create an X1, Y1 line. Then I can project up all 4 points perpendicular to the X1, Y1 line, or perpendicular to the line AB. So I can project up point D. Point B, point C, and point A. And like we would have done before, we can now take the heights from the XY line up to find our heights. So for example, the height of A will be the distance between the XY line and A, which is 10 millimeters. So along the line A, I'll measure up 10 millimeters, and I'll do the same with the others. You can use your compass if you want, it's quicker. I'm just going to do it this way because I don't have a compass just here. I'll get one in a second. And point D is up a height of 60. So now I have point D1, point B1, point C1, and point A1. So A joins to C, and A joins to B, and A joins to D. So I'm going to join them up now. So A to D is green, A to B is green also, and B to D is green. ABD is now shown there. I can now get my purple pen or marker or pencil, and I can join up ABC. So A to C, C to B, and A to B. And what we have just here is the true length of the line of intersection. Now what we're going to do is we're going to project up along this, and we're going to create what's called an X2, Y2. So I'm going to line up, I'm going to create my X2, Y2 so that it's perpendicular to the line of intersection, just like this. And this time I take my distances back from my x1, y1 to my points here. So I come back to the previous xy line and measure this right now. Because this is such a large distance, what I can do is I can create what's called a datum line. So I can project this back down, just like this. And rather now than measuring this entire distance here, I'm just going to measure from this line, and I'm going to measure how far back all these points are, and then I can measure up along my x2, y2. So first of all, I'll project up all my points. So I'll project up points A and B here. D and C. So point C is going to be on my datum line, my DL. Point C will be here on the ground. It's actually the vertical plane if we visualize it that way. Point B will be this distance here. So I'm going to take that on my compass. Just like that. And I can find point B and step it up. That will also be the same distance as point A, as you can see. So now I have point AB, AB2 this time. I have point C2, and I just need to find point D2. So I'll get the distance for point D, just there like that. And I'll take that, step it off. I have point D2, and now using my colours, so AB to C will be purple, and AB to D will be green. I've now found my dihedral angle, so I'm just going to draw in a little arc. And I can label that dihedral angle. So that's the angle that the two triangular planes make. I'll just find another set square. And basically, if I was to get this and to put a ruler against it like that, I have a common line of intersection just here where my thumb is. If I stand that up, you can see the angle in between them two surfaces, just like that. So that's what we've done. First off, we had something like this. So we were shown 3 planes. Then we found this edge here. So you looked at perpendicular, so I'll leave it horizontal. And then you looked along it. So what you could see was this angle here in between. That's what we're doing on the paper. Just seeing this angle in here between where my fingers are. So it's getting more obtuse, getting more like a right angle just there. And then if it was acute, you would see a little V shape like this. Hopefully that makes sense and it helps.